Hi everyone, let's continue with subtopic 4.4 Intermolecular Forces of Attraction for van der Waals forces. At the end of the lesson, you should be able to describe van der Waals forces, and there are two of them. The first one is dipole-dipole interaction, and the next one is London forces or London dispersion forces. And next, we will look at hydrogen bond. The strength of intermolecular forces or IMF are responsible for it will affect the physical properties of a molecule. And there are two types of intermolecular forces. The first one is van der Waals forces, and the second one is hydrogen bond. This is the example of intermolecular forces. So you can see one molecule of HCl here with another molecule of HCl. In between them, you will have intermolecular forces of attraction. You need to make sure that you are able to differentiate yang di tengah ini between H, hydrogen and Cl, it is covalent bond. Okay, tapi kalau between molecule, intermolecular forces adalah the forces of attraction, between molecules. Okay, so it is between the molecules. There are two types of van der Waals forces. The first one is dipole-dipole forces, or we can also call it as permanent dipole. The next one is London dispersion forces, and normally we call it as temporary dipole because the sifatnya adalah secara temporary, tidak tetap. And the intermolecular forces, the arrangement are, the weakest is London dispersion forces, and then the second one is dipole-dipole, and the strongest intermolecular forces is hydrogen bond. So let's look at dipole-dipole forces, or we call it as permanent dipole. It exists between polar molecules. So let's see, if you have HCl as your molecule, so it's between one molecule of HCl with another molecule of HCl. You will have in between here the dipole-dipole forces. Next, the strength of the dipole forces depends on the size of the dipole moment. Okay, so refresh back. For topic 4.2, you already learned about the dipole moment, the polarity, and for dipole moment, actually you have certain specific value. The higher the dipole moment means the more polar the molecule is, therefore the greater the strength of the dipole-dipole attraction. Okay, so contohnya kita ada HCl and kita compare dengan HBr. So we know that HCl is more polar compared to HBr. Therefore, the dipole-dipole forces in HCl, hydrogen chloride, are stronger than compared to HBr between HBr molecules. Next, we will look at London dispersion forces. For London dispersion forces, it exists in all atoms and molecules. So on the average, the negative charge of the electron in atom will spread evenly around nucleus. So nucleus ni di bahagian tengah. So all the negative charge will be spreading around the nucleus. Okay, but at certain moment, the spreading of the electron boleh jadi dia akan bertumpu at one side. Contohnya, dia akan lebih berat on this side. Okay, so means this side lebih partially negative because you have more electron attracted to that particular space. Okay, compared to the other side, which is this one will be partially positive. At this instant, at this moment, the atom or molecule will has or become a small instantaneous dipole, and this will induce a dipole on the neighboring atom. So maksudnya ini kamu punya atom. Okay, so ini adalah your atom. Okay, so originally it is in this position, the first one. Okay, but sometimes it can be like this. Means satu side akan bertumpu dengan elektron compared to the other side. So when it become like this, dia akan menarik ataupun induce, the correct word is induce a dipole, a temporary, this one is the temporary dipole lah. So that is why just now Miss ada mention about temporary and permanent kan. This one is a temporary dipole. Dia akan induce a temporary dipole on the neighboring atom. So ini atom A, B. Okay. So B ini dalam keadaan normal. The negative charge are spread evenly. Okay. Tapi bila dia induced by A, so it will become like this. Due to the electron repulsion, okay, so remember electron dia akan ada repulsion, a temporary dipole on one atom can induce a similar dipole on the neighboring atom. Maksudnya atom yang close to it. Okay, dengan syarat dia sangat-sangat dekat. And can cause the neighboring atom to be attracted to one another. So maksudnya dia akan ada attraction di tengah ni. Okay. Tapi dengan syarat jarak antara dua atom tu mestilah sangat-sangat dekat. So you know that in a space, atom tu move around kan. So when the atom A dengan atom B tu move closer towards atom A just now, and then atom A ni akan induce a temporary dipole. So atom B yang ada evenly distributed electron, dia pun akan ada similar macam atom A. So this interaction is what we call as London dispersion forces. And remember that this is a temporary dipole. So maksudnya bila at certain point, dia akan back to normal. The electron akan evenly distributed. Okay. And one more thing, only significant maksudnya hanya akan nampak kesannya when the atoms are very close to one another. Maksudnya kena dengan jarak yang sangat dekat between the two atoms. Okay, so let's look at the example. So first, Miss ada dekat sini He. Okay, so helium atom with another helium atom. Okay, so inilah. So helium A dengan helium B, At normal condition, your electrons are evenly distributed, so no polarization. But at certain point, okay, dalam atom helium tu sendiri, the electron can be bertumpu at one side. So you can see one side here, partially negative because all the electrons are focused on this side. So dekat another side here will be less electron. Okay, so this one dia akan induce instantaneous dipole, and then it will induce dipole on atom B pula, the closest one next to it. Okay, so atom B, helium B also will has instantaneous dipole. So kalau di sini positive, okay, this side akan jadi negative. So remember, dia akan attract yang opposite lah. Okay, so ini just gambaran between two atoms. So imagine dalam kamu punya reaction tu ada banyak atom. Okay, so let's look at molecule hydrogen gas pula. Sama juga konsepnya. So ini hydrogen H2 bonded to one another. So another molecule of hydrogen, hydrogen B, hydrogen gas. So ini kita namakan AB lah. So at first, no, there's no polarization. But at certain point, electron tu dia akan move to one side. So one side will be more electron and one side will be less electron lah. Ini. Okay, so ini. So hydrogen hanya satu electron kan. So this one will have the electron and this one no electron or less electron. Okay, so it will be partially positive. Therefore, they akan induce the neighboring the neighboring molecule, which is hydrogen H2B, the closest molecule. So, this side akan jadi bertumpu dengan elektron. So, partially positive akan attracted to partially negative. Factors affecting the strength of van der Waals forces. There are molecular size, molecular shape, and polarity of a molecule. And all of this will result in the boiling point of the molecule. Means the stronger the intermolecular forces, you need more energy to overcome the intermolecular forces. Therefore, it will result to higher boiling point. First, let's look at molecular size. The larger the molecular size means you have more number of electrons. Means you will have more space or more distance for the electron to move around. Therefore, it will have a temporary dipole in the molecule. Let's look at the first factor, which is molecular size. The number of electron increase or the increase in the molecular weight will result to a stronger van der Waals forces. Means when you have a stronger van der Waals forces, you will need more heat or energy to overcome the forces of attraction. Okay, therefore, you will have higher boiling point. So let's compare molecule of CH4 with molar mass of 16. It will have boiling point of 112.15 Kelvin. But if you compare with C4H10 with greater molar mass, it will have greater boiling point compared to CH4. Next, the factor of shape. It is very significant in organic compound. If you have a long and straight chain molecule, means it will be like this. Okay, so let's say you have a long and straight chain molecule with another straight chain molecule. Okay, ini adalah intermolecular forces. So you need to consider the forces between molecule. So contohnya you have this CH3 ini. CH3, CH2, CH2, CH3 with another molecule butane. Okay, sebab ada 4 carbon, so most of you already learn organic compound. So kalau ada 4 carbon, it is butane. And then between one molecule of butane with another molecule of butane, akan ada intermolecular forces here, between here. Okay, so if you compare with the next molecule, okay, so Miss lukiskan yang ini, CH3, CH3, and kalau dalam bracket begini biasanya di dalam keadaan branch. And then, okay, masih lagi molar mass yang sama, you have 58 and 58. But what are the difference here? Satu dalam keadaan, ini A lah, Miss labelkan A, and then this is B. Okay, so for your molecule, the B molecule here, it will be in a branch molecule. So with another, okay, untuk molecule B, you have branch molecule. So bila branch, the shape will be begini for the first one, and then the second one, you can see the surface area in contact will be smaller. Okay, so surface area in contact for both molecule here will be smaller compared to the structure butane. Okay, kalau kamu compare these two lah. Therefore, because of the surface contact area berbeza, it will result to a different boiling point. So for the first molecule, you will have boiling point of 272.65, and then for B, you will have 261.54 Kelvin. Okay, so you can see the explanation here. Long and straight chain molecule will have larger surface area in contact compared to branch molecule. Okay, so ini adalah long and straight molecule, and for B ini adalah branch. Okay, branch tu maksudnya ada cabang lah. You can see here bercabang. Okay. Greater contact area or surface contact area between straight chain molecule, and therefore it will has stronger van der Waals forces. That is why boiling point is greater ataupun higher lah. Higher for the first molecule. The next factor is polarity of the molecule, and you must compare with the comparable or similar weight of molecule. If you compare the similar weight, you will see that polar molecule will have higher boiling point compared to the one that you compare non-polar because it will has a stronger dipole-dipole interaction. Therefore, this is because of the differences in the electronegativity. Because of the polar molecule, of course, it will be more polar. Therefore, the strength of the van der Waals forces will increase. Let's look at the explanation for polarity of molecule. So you have two molecules here so that we can compare. So first I'll label it molecule A and molecule B. So molecule A is CH3CH3. It is an ethane, and then the molar mass is 30 gram per mole. The polarity of molecule is non-polar molecule, and the boiling point is 184.5. Next, the next molecule is CH3F. So the molar mass is 34 gram per mole, and it is a polar molecule. So kalau kamu masih lagi confused polarity of a molecule, refer back to my previous video about polarity. Okay, so you can see the polar molecule, the boiling point is slightly higher, which is 194.7 Kelvin. Okay, so the explanation is why CH3, this ethane. Okay, so untuk ethane, it is a non-polar molecule. That is why it will only has London forces. But for polar molecule, it will has both London forces and dipole-dipole forces. Okay, the one that important things that you need to remember, the strongest intermolecular forces is hydrogen bond, which we will learn later. This is the strongest, and then the second strongest is dipole-dipole. And the weakest is London dispersion forces. Okay, so you know that the arrangement will be dipole-dipole forces is stronger compared to London forces. That is why CH3F has higher boiling point compared to CH3CH3.